The next presentation is titled An Open Source Managed File Transfer Framework for Science Gateways, and it is presented by Dimuthu Wannipurage.
Can you hear me now?
Yes.
Yes. Yeah. Hello. I'm Dimuthu Wannipurage, and I'm a research engineer at Cyberinfrastructure Integration Research Center at Indiana University. And I'm going to talk about a product called Airavata MFT, which is an open source managed file transfer framework for science gateways. So before going into the product details, I would like to go to some of the challenges we have seen in specifically in the file transfer scenarios in gateways. So the first one is the cross storage transfers. So basically you might have different type of storage types, and then how do we do the protocol matching and the protocol translation between different storage types when if you are data transferring to a gateway. And the other one is the performance, as always. But the performance might go in two ways. For example, let's say if you have a private dedicated link across two endpoints, then you can utilize the maximum bandwidth. But in some cases, you are transferring data to a public link. In that case, you have to be much fair and give the opportunity to the other transfers as well. And the other one is the data path optimization. So this comes into the picture in the cases where you have endpoints having multiple network links, and the transfer solution should be smart enough to pick the right network link to get the maximum throughput, or in some cases, even you have to reduce the network cost, especially in the cloud endpoints. The security is also very important into the cases where you have sensitive data sets to transfer. So in that case, you have to go through more constrained and secure paths. But in some cases, you have public data sets, which doesn't need that much of security. But in that cases, you can focus more on the performance of the data transfer. And in either case, you have to be very careful about the integrity, and the integrity should be preserved at the end of the transfer. And this is like a very recent use cases, and like very like famous these days. People are bringing their own storages into the gateways, especially with the advancement of the cloud endpoints and cloud resources. So in that case, the gateway should be able to plug new storage endpoints easily, and it should be accessible for the end users to the gateway APIs or the UIs. So these are some of the data science solutions that we have observed. We categorize them based on their open source, community adoption or the deployment mode. So we have like discussed about this in detail in the paper. So then I would like to go back to like what's Airavata MFT. So Airavata MFT is not itself a product. Why we call it like a framework for people to deploy their own managed transfer platforms. So it's designed in a way like it's fully pluggable. You can configure your own credential backend and the resource backend to the MFT framework. So then you don't have to manually copy or clone the credentials of your existing gateway into the MFT framework. So the MFT framework can automatically call to your existing backend and fetch the data. And it has easily extendable protocol interfaces. For example, you can write your own protocol implementation for the data transfer, or you can even improve the existing protocol implementation like SFTP, and you can easily plug the new version. And so the Airavata MFT doesn't come with a fixed deployment pattern. So it could be vary based on the quality of service you want, and even the security, and even the maintenance complexity you want. So I will cover this topic in more detail in the later slides. And the other aspect is that sometimes it will be a concerning matter when the data flows through your gateway backends. So if you use like the MFT platform like this, like there are ways you can isolate the data paths and the control paths from the gateway backends. So in addition to that, it has active metadata capturing of the transfer, the files that have been transferred, and it's doing the replica management as well. So so um, so and more importantly, so the Airavata MFT is an open source framework, and it's Apache 2 license, and it's currently managed under the Apache Software Foundation. So anyone can contribute and watch the code and see what's going on. So this is a very top level architecture of the Airavata MFT. It has at the top layer, it has external APIs for the users to submit transfer requests, and it has the framework extensions. As I mentioned earlier, you can plug your own credential backends and the resource backends of your existing gateway backends. Then it has the metadata collection, data transfer, and data browsing components in middle, and underneath it has the MFT agents, we call it, which are the actual agent which are doing the communication across the different type of storage endpoints. So in the outside, we have different kind of cloud endpoints, even HPC, or even you might have a databases. So the MFT agents are smart enough to talk to these endpoints according to the protocol they support. So I would like to go to a simple scenario of how the files are being transferred using the MFT framework. So the use case is you have a data store one, it's having some file, and you need to transfer the file to the data store two, and then you install MFT agent. We call this pattern as the end-to-end transfer. Um, First, the so this is the MFT framework that I mentioned. First, the user sends a request to the API service. So the API service gets a request and put it to the console, the event-driven message bus, and the message is forwarded to the MFT controller, which is the coordinator of all the services. So then it reads the message and validates whether this is a right request coming from the right user, and then it sends to the right MFT agent. So the agent then deserializes the message and talk to the resource service to get the resource metadata of this particular file, and talk to the secret service to get the credentials to talk to the data store to. So once it has received all the information, then it starts to get the data from the local file system and push it to the data store to using the credentials it got from the secret service. So this is like a very simple diagram which shows the previous use case. We call it end-to-end transfer. So to do the end-to-end transfer, you should have agent installed on either side, or you can have agent installed on both sides. Um, it's your preference. And so the MFT platform is sitting outside and sending the control signals, and the data path is only between the two endpoints. So this is recommended in the cases where you have sensitive data transfer requirements. So even like if you need some high throughput data transfers, you can use that because there's no any third party entity involved in the transfer. So the second use case is we call it zero intervention, because in some cases, it's not practical to install agents or some binaries on the storage endpoints because due to the security or the policies enforced by the endpoint. So in that case, you can use an external agent to pull the data with according to supported protocol of the source resource and push it back to the destination endpoint according to their supported protocol. So here also you can put the agent inside the network boundaries, and you can control those agents from the MFT platform from the outside. Here also the data path and the control paths are separated, and this could be useful in the cases where, as I mentioned earlier, in the cases where you don't have any authority, and you might and the data transfer is not like the sensitivity of the data is not that much critical. So, and this is another extension of the zero intervention transfers. You might you might be able to define DMZ boundaries inside the MFT platform. So the MFT platform is smart enough to keep the data inside these DMZ boundaries and select the right agent to transfer data in between the storage endpoints. And this is another use case. So you might have the access to multiple cloud endpoints by different vendors, and if you need to transfer files in between different vendors, you can use public cloud agents to do the transfer and use the MFT platform to signal the agents to do the transfer operations. So this is a little bit advanced use case. So for example, your laptop have contain some research data, and you need to expose them into the public endpoints. And in that case, you can use the MFT platform to expose them using even through the net or firewall provided by your service provider. So that's all about the use cases. And so now I'm going to briefly go through, like, let's say you have a gateway, and how do you integrate the Airavata MFT platform. So first thing, as I mentioned, like earlier slide, you need to have plugins for your credentials and resource backends. Once you have configured that one, then obviously you have to change some code fragments of your gateway. Instead of doing the transfer manually, you can talk to the MFT APIs, and it provides all the transfer and monitoring endpoints. So if you are more interested, you can do some advanced integrations, like you can look at all the storage endpoints as a one single global file browsing view, or even you can do the searching and indexing through different endpoints, and you can do the data grouping or repository management if you want. So all are provided through the MFT API. So these are like so because our framework is very extendable, so we are looking through new innovations and see what are the advancement of the technologies in the area where the file transfer happens. So the first one is we are currently looking at how quick protocol, which is a UDP based file transfer protocol developed by Google, can be used for our agent-to-agent transfer scenarios. And then we are looking at RDMA-based data transfer, specifically in the clusters where they contain the RDMA supported network cards. And in addition to that, we are actively looking at how we can improve the data encryption. And usually data encryption doing on the CPU could be like a very expensive operation, and there are some technologies where you can do the encryption at the chip level, and we are looking at those opportunities and see whether we can improve our overall transfer performance. And then so that's all about the Airavata MFT for now. And please go ahead and check out our code from our GitHub page, and it's deployed under the Apache umbrella. And you can go and look at the issues, and maybe like you can give your feedback as well. And because the project is still at the very early stages, and we are actively working on some feature improvements, and you can also contribute. So these are some interesting ideas that we are like planning to work in the future, but we haven't planned yet. A plan about the development iterations. So you can maybe like contact us and give your feedback as well. For example, we are doing some research on smart network path detection across agents, and we are doing some work on transfer time detection before initiating the transfer based on the historical data and machine learning models. And then we are planning to see some automatic fallback operations across agents, which is a distributed system problem. And these are all open problems, and we are always open to get the feedback from you all. Thank you.
Thank you, Dimuthu. Are there any questions for him? If not, maybe I can ask one. So in at least in the for when they're in the HPC resources, when people are trying to transfer files, usually they have like gazillion, like 10,000 files that they want to transfer.
Mhm.
When they're doing that, is there any like data management practice, like in the sense you want to like maybe compress them, put them as a zip file to transfer, just to improve the network latency? Is something that you thought about?
Yes, it's on our pipeline, but right now we don't support that one. We are transferring file as it is, but it's yes, of course, there's a it's a very valid use case. The only thing is that it can be done only on uh, the file system, on the like HPC file system. We can't do that on probably on the cloud endpoints. uh, so we might be considering that in future, but not right now we don't do that one.
Okay, thank you.